This is my third video in my module on properties of exponents, in which we're going to confront how to use the properties of exponents when simplifying expressions that involve scientific notation. So just a real quick kind of recap of what scientific notation is. It's a way to write really large and really small quantities kind of as approximate values by expressing them as multiples of 10. Okay, so we say a number in scientific notation is any number that looks like this. C, which is our number here, times 10 to the nth power, just, powers of 10. Recall that when you take something times 10, you're really just shifting the decimal to the right. And every time you divide something by 10, you're shifting it to the left. And so we say these things must be true about our number. It's written as C times 10 to the n, where C is a number between 1 and 10. Okay, so, and it should say less than 10 here, not less than or equal to 10. But we also say n, this power of 10 here, is an integer. So examples of scientific notation numbers include these ones here. We say like 2.99 times 10 to the 8th. This would mean the same thing as 2.99 times 10 8 times. And so when we say 2.99 times 10 to the 8th, what we're really trying to express is the number 2.99, where our decimal has been shifted once, twice, and 3, 4, 5, 6, 7, 8 times to the right. And for each one of these gaps, we would actually fill in a 0. 1, 2, 3, 1, 2, 3. So when we express the speed of light as 2.99 times 10 to the 8th, we're really saying 299 million meters per second. And the same thing is true for like the width of a water molecule. The reason why I give this as an example is because we're talking about a negative exponent now. So this negative exponent, recall from our previous video on properties of exponents, a negative exponent is the same thing as the reciprocal of what we're given. So, whoops, keep screwing this up, times 10 to the negative 8. We're really saying 2.55, not times 10 to the negative 8th, but the same thing as if we were to move this base down to the basement now, times 1 over 10 to the positive 8th. Okay, its exponent would become positive as soon as we move its base over this bar on the fraction. And so this is essentially saying the same thing as divide this number by 8. Or sorry, divide this number by 10, but do it 8 times. And so we actually get this. I'm going to spread this out to the right a little bit here. We're saying take where the decimal was and shift it 1, 2, 3, 4, 5, 6, 7, 8 times to the left here. So we'd get 0.000000025, and it seems that I have not included my units here. I'm going to assume I meant in meters, like the metric system quite a bit. But we say, okay, this is what we would end up with here. Okay, so that being said, we can use the way of writing this in scientific notation to our advantage when we operate with them, at least multiply and divide numbers in scientific notation. We can use the properties of exponents. So just take a look at this one example. I say currently the USA has a population of approximately this many people. And I know it's not this, but it was close when I pulled this number. We say with a GDP of about 15, looks like, let's see, 1,000 million billion trillion dollars. So we say estimate the per capita per person GDP of the United States. So really what we want to know is this dollars per person. So here's what we could say. We could take the number of dollars, 150900000, and another 3 zeros, and divide it by the number of people, 311591917 people. And this would essentially give us the number of dollars per person in the United States. Now, since these figures are so inflated, what we could do instead is let's write them in scientific notation. Okay, so the way you write a number in scientific notation is kind of an easy thing to do. You start with this. From left to right, we want to find the first non-zero digit in the number. So it's 0, 0, 0, 0, 0, 0. The first non-zero digit in this number we run into is 1. We're going to put a little arrow underneath this. We're going to say this is where I would prefer the decimal to be. So if that's the case, here's where the decimal is now. At the end of the number, here's where it should be. We're going to rewrite this as 1.5, and I'm gonna round this 0 up to a 1 since this is a 9 right next to it. 1.51 times 10 to the what? Now, here's all I need to do. We're going to count from where the decimal should be, this arrow right here, to where the decimal is. And so I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spots. So what we're really going to say is since I counted 10 spots to the right from where it should be to where the decimal is, I'm going to say it's a positive 10. So this is how many dollars approximately we have in GDP. to convert this number of people into scientific notation. Again, from left to right, what is the first non-zero digit in this number? And it happens to be a 3. So we're going to put an arrow directly to the right of this 3 and say, this is where I want the decimal to be. So this comes out to be 3.1, and to round this 1, we see it has a 5 next door. We should probably round it up to 2. So 3.12 times 10 to the what? Well, in order to figure out that what, we're going to count from where the decimal should be to where the decimal is currently, which is at the end of the number. And so I count 1, 2, 3, 4, 5, 6, 7, 8 places. So 10 to the 8th, and this is people. So now to re-express the original quotient that we had here, we have 1.51 times 10 to the 10th dollars for 3.12 times 10 to the 8th people. And in order to find the approximate GDP, what we could essentially do is this. We could take this first value here divided by this first value here, and then we'll proceed to take 10 to the 10th divided by 10 to the 8th. The nice thing about it is this. When you take 10 to the 10th divided by 10 to the 8th, this is dividing two things with the same bases. And we should be familiar at this point with saying until dividing two things with the same bases, you just subtract the exponents, the top one minus the bottom one. So 10 to the 10th over 10 to the 8th is 10 to the 10 minus 8, which is 10 squared. So our answer, whatever we get here, we're going to get a number times 10 to the second power. Okay, and so now this is just an approximation that we're doing here. We could pull out a calculator, 1.51 divided by 3.12, but that kind of defeats the purpose of just getting an approximation in the first place. This is like 1.5-ish over about 3-ish. Okay, so we'd say 1.5 and 3. 1.5 goes into itself once, and 1.5 goes into 3 about 2 times. So this is about a half. So we'd say about this. And so we'd say the GDP is about this times 10 squared, okay? So this is our dollars per person kind of figure. And by the way, scientific notation says times 10 twice. That means move your decimal to the right twice. If we did so, we'd say it's about $50 a person. So yes, I'm using skewed figures here, not really the case. But here's the thing, about $50 a person per capita. The point of this exercise is to know how to write a number in scientific notation and to know how to multiply and divide numbers in scientific notation. You operate on the numbers in front here, and then you just either use your product or quotient property with your tens. Cool.